NASA launched the powerful James Webb Space Telescope to explore the early universe. JWST detects infrared light, allowing us to see billions of years into the past. This mission is high risk and costly, but promises breakthroughs in understanding stars, galaxies, and possibly life beyond Earth. Hello friends. The biggest and most powerful space telescope in the world was launched by NASA some days ago. It's called the James Webb Space Telescope. Using it, you can time travel, sort of. I mean, you can't literally go back in time, but with this, you can glimpse history, and not just recent history. I'm talking millions, even billions of years ago, more specifically, 13 billion years. The universe began with the Big Bang, 13.8 billion years ago. This telescope can look back 13 billion years, about 0.7 billion years after the universe began. But how is that even possible? Come, in today's video, let's understand this phenomenon. Lift off from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe. Nature has its way of being even more creative than we are. So, we've always been surprised by what we see in the sky. That's why building a telescope has always been interesting. I don't think human beings are obligated to learn about space, but it would be foolish and short-sighted not to. It may hold the key to our survival. What will JWST study? The most special thing about this telescope is that it's mainly designed to detect infrared light. When you look at the sky with a normal telescope, you only see visible light, the light your eyes can detect. Remember studying the electromagnetic spectrum in school. It includes X-rays, ultraviolet rays, radio waves, microwaves, and a small range of visible light. Normal shop-bought telescopes only let you see visible light from blue to red. Red has the longest wavelength, and as you may recall, the longer the wavelength, the easier it is for waves to pass through obstacles, like radio waves, which can even pass through buildings. Infrared has a longer wavelength than red, but we can't see it with our naked eyes. The advantage of using a telescope to detect infrared can be seen in this comparison. The left image, taken by the Hubble Space Telescope, shows dust and gas clouds. The right image shows what's behind them. Thanks to infrared, we get a clearer, more high-definition picture. Infrared means below red. Its frequency is lower, and as frequency and wavelength are inversely related. Anything that radiates heat emits infrared waves. Humans, animals, the sun, fire. That's why night vision goggles, often used by soldiers, detect infrared. Since stars, galaxies, and planets radiate heat, JWST can capture their infrared signals. The redshift. When a telescope looks at stars billions of kilometers away, the light has traveled so far, and since the universe is expanding, the light's wavelength stretches. This is known as redshift. The light shifts toward the red end of the spectrum. Gold mirrors. The bigger a telescope's mirror, the more light it captures, and the better the resolution. That's why newer telescopes have bigger mirrors. The Hubble's mirror is much smaller compared to JWST's. JWST's mirror is coated with 24-karat gold, as gold reflects red light best. But the telescope itself will also emit infrared waves since it radiates heat. To avoid interference, it must operate at extremely cold temperatures, -223 graus Celsius. That's only possible in space. But in space, sunlight can heat objects rapidly, like on the moon, where temperatures jump from -70 degrees Celsius to 120 degrees Celsius. To avoid this, JWST needs protection from the sun. A special sun shield shaped like a kite and the size of a tennis court protects JWST, made of a material called kapton. It has 5 layers, each thinner than a strand of human hair. There's a vacuum between the layers, and each one is coated with aluminum, while the two facing the sun have an additional doped silicon coating. Telescopes orbit. Unlike Hubble, which orbits close to Earth, JWST is placed 1.5 million kilometers away, at a spot called the L2 Lagrange point. L2 lies opposite the sun and orbits with Earth, keeping the sun blocked by Earth's shadow. It's like shielding your eyes with your hand to see more clearly. A higher risk mission. NASA identified 300 single points of failure in this mission. If even one fails, the entire mission could be lost. It cost $10 billion, forcing NASA to pause other research. The European and Canadian space agencies also contributed. Scientists hope to use it to study how stars and galaxies formed after the Big Bang. Hubble could look 1 billion years after the Big Bang. JWST can look back to just 0.3 billion years after it happened. Time travel. How is it possible to look into the past? Light takes time to travel. For example, The sun's light takes 8 minutes to reach Earth. If the sun disappeared, we'd only know after 8 minutes. So, in a way, we're always looking 8 minutes into the past when we see the sun. If someone looked at Earth with a powerful telescope, they'd see Earth as it was 100 million years ago, possibly even dinosaurs. The same logic applies on a larger scale. Stars that are billions of light years away, when we see them, we're seeing how they looked billions of years ago. Theoretically, if we were on a planet 100 million light years away, but practically, it's impossible for now. We'd need teleportation or faster travel to make that possible. What's next? It will be interesting to see what new planets JWST discovers. Could it find an Earth-like planet with life? Time will tell. Hope you liked the video. See you in the next one. Thank you very much. Don't forget to like the video and subscribe to the channel for more amazing content.